Hey everybody, welcome to lesson number 2, counting principle. If you liked the last lesson about factorials, you'll like this one too. Doesn't really have much to do with it, but it's still kind of a fun concept. Let's look at what count actually means here. So in mathematics, a count would be the number of ways an event can happen. So we're going to be talking about very specific events. So maybe, for example, a game of some sort that we might be playing. Um, but regardless, they're going to be very specific situations that have specific outcomes. So let's look at our first example. By the way, I'm going to try to keep this short for you as far as the video goes, but there's a lot of writing, so you might need to pause in order to write down the situations. So if you need to, go for it. So our first problem says numbers 1 through 10 are in a box. If you draw a number, write it down, and return it, then randomly draw a second number, how many ways can you obtain a sum of 14? So first of all, we have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 inside of a little box. We're going to draw a number, we're going to write it down, and put it back in. What that means is that on the second draw, we could possibly get a duplicate number, right? If we had picked out 1 and put it back in, we could possibly pull that 1 out again. The second part of this says that we're trying to figure out how many ways to obtain a sum, meaning addition, up to 14. So let's think about it. The smallest number that I have here is 1, and the largest I have is 10. If I add those together, it's only going to give me 11. But if I move up to 4 plus 10, that'll give me the 14. So that's one combination. If I pull out a 5, I would have to pull out a 9. If I pull out a 6, I would have to pull out an 8. But now here's where it's interesting, because I could pull out a 7, and I would have to pull out a 7 on the second pull as well. So far, 1, 2, 3, 4 different opportunities. Now, I have to consider the inverses of these, or the opposite, not the inverses, I'm sorry, bad phrase, but like the reverse order of these, right? If I pull out an 8 on my first pull, I would have to pull out a 6. If I pull out a 9, I would have to pull out a 5. And if I pulled out a 10, then I'd have to pull out a 4. So this is my first pull, this is my second pull. I'm not repeating these because this was the first number regardless of which time I pulled it. So I have a total of 7 different ways to obtain a sum of 14. Remember, order right now somewhat matters because they're saying that you pull the number out first and then put it back. So it doesn't matter which way we're pulling these out. So using the same system as above, how many ways can you obtain a sum of 12? All right, well, now we're going to start again with the lowest number, which is 1. 1 plus 10, the highest number is 11, so it still doesn't work. But if we start with 2, 2 plus 10, that gets us 12. Then we could do 3 plus 9. Then we could do 4 plus 8, 5 plus 7, 6 plus 6 again, because we're allowed to pull the 6 out twice, 7 plus 5, 8 plus 4, 9 plus 3, and then 10 plus 2. That's as far up as they go, and that's the most that we could possibly do for 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 different ways we could obtain a sum of 12. So you're going to try using that same system. How many ways could you obtain a sum of 11? Pause the video and resume when you're ready to check. Alright, so let's see. The smallest number would be 1 plus the highest number of 10. That gets us the 11, so that right there worked. If I pull out 2, I would need 9. If I pull out 3, I would need 8. If I pull out 4, I would need 7. If I pull out 5, I would need 6. And now I can start basically doing these in reverse, because I can't pull out any numbers twice. That wouldn't give me an 11. So 6 and 5. 7 and 4, 8 and 3, 9, 2, and then 10 and 1. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different ways to obtain a sum of 11. Pretty interesting, right? Same system gave us completely different ways of looking at that. So now, if you think about it, we can start thinking and considering things like probability. That's why this is considered part of the probability unit. So let's look at a different situation. Right, this time when you pull out a number, you're going to keep it out. You're not going to replace it. Okay, but then you're going to pull out a second number. Now how many ways can we obtain a sum of 14? Well, we already know from earlier, right? We would have 4 plus 10. We could have 5 plus 9, 6 plus 8. But here, this 7 plus 7 doesn't work because when we pulled out the 7 the first time, we can't replace it. So there's no way for us to pull out a 7 a second time in a row. 8 plus 6, 9 plus 5, and 10 plus 4, those all still exist. So it's the same kind of idea where we're still adding up to 14, but if we can't replace a number or use it twice, you're not going to have that situation. So this time, there's only 6 ways. Right, so pretty interesting. That's considered a type of game. We're going to look at some other situations too. So let's look at what the fundamental counting principle is itself. This is a little wordy. The very bottom of that definition is the real meat and potatoes of it. But here it tells us that the fundamental counting principle, if we have event E sub 1 happening m sum 1 ways, and event E sub 2 happens m sub 2 ways. So these are really the important thing. How many ways can this event happen? How many ways can this event happen? The number of ways both events can occur is m sub 1 times m sub 2. So, by the way, this could happen with multiple events too. And here's what I mean, right? This event could be something like the type of pants you have to wear. This event could be the type of shirts you have to wear. You could also have an event maybe that you have hats or different socks, right? So those events, you have different number of pants that you have. You might have a different number of shirts that you have. So now you have a different number of ways those events can occur. So now we'll start to multiply. All right, so we're going to look at a couple of examples. Again, if you need to pause the video to do this, not a big deal. To copy it down is what I meant. So anyways, here we go. A flower shop sells bouquets of flowers. They have 15 types of flowers, 8 types of greens, and 5 types of ribbon. If the cheapest combination is one from each category, how many possible combinations are there? So if we're going from the flower category where there's 15 options, and then the greens category with 8 different options, and then the ribbon to wrap around it has 5 different options. All we have to do is multiply those together. 8 times 5 gives us 600 different options. So maybe you can have a rose with light greens and blue ribbon. I don't know. Who knows? But there's 600 different possibilities that you could possibly come up with that combination. All right, another one. Again, if you need to pause the video, write it down, go for it. It says a new sports team has to make a new logo. There are 50 animal mascots to pick from, 12 primary colors, and 4 secondary colors to make up their uniforms. How many options do they have to choose from? That's a kind of cool one. All right, so the animal mascots to choose from, there are 50 different animal mascots for their logo. There are 12 primary colors to choose from, and I need 4 secondary colors. That's probably like black, white, gray, something like that. Be my guess anyways. Anyways, the number of combinations that you have would be 2,400. Anybody that plays like Madden, football, or even like the baseball and basketball games where you get to create your own team, you have a situation just like this, right? You have all sorts of new logos that they come up with for you to create your team, and then they have so many different color options for you to choose from. So there's so many different teams that you could possibly come up with. That's why those games are so much fun. You get to make up your own teams. Anyways, you're going to try your own problem down here. Pause the video and resume it when you're ready to check your answer. Alright, so let's see what happened. You have an ice cream shop that has 20 ice cream flavors. I'm just going to start writing some stuff down here. 12 candy toppings and 4 sauces. A kid's deal lets you pick one of each. Okay, so we can choose all from the 20, all from the candies, and all one from those 4 sauces. How many unique options are there if you get one from each? 960. Chocolate ice cream sprinkled with peanut butter sauce. Chocolate ice cream with gummy bears and fudge sauce. Mint ice cream with Reese's Cups and, I don't know, some other kind of sauce, butterscotch, right? All different options, 960 in total. Pretty cool. Now we can think about things like commercials, right? They everyone advertises. So you got 960 options. Anyways, Verizon is thinking of adding new phone numbers to Rhode Island. They have said that if the first 3 digits must be even, none can repeat, while the last 4 digits must be an odd number but can repeat. How many new phone numbers can be added this way? Alright, so first of all, in Rhode Island, right, 401 is the area code, but then we have 7 phone digits after that. Now, this is not the most specific, so I'm going to clarify something for you. Right? If we're talking about even versus odd digits, you have 0, which is a telephone digit, which could in some ways be considered an even number. I'm not going to consider an even number for this particular example. I guess it would have to be more specific if they wanted to be considered zero, even, or odd. It's technically neither, but if it comes at like the end of a 10, it makes it even, but I'm not going to consider it. So we're going to use, for the first digits, they have to be even. So we have 2, 4, 6, and 8 to choose from. So for the first digit, there's how many options? 4. Now let's say that we choose any one of them randomly, it doesn't matter. If we use it here, we can't repeat it, which means that we're down to only 3 choices here. Again, we randomly choose one of those, now we only have 2. Okay, so those are all the number of possible digits we could put in each of those spots, because we can't have anything repeat. Now the last part of this, right, for the odd numbers, we have 1, 3, 5, 7, and 9, but we're allowed to repeat on any of these, right? It says we are allowed to have repeats, right, but can repeat. So we have 5 here, and because we could possibly pick them again, right, there's always an option of having 5 in each. So we're going to multiply all those. 4 times 3 times 2 times 5 times 5 times 5 times 5. By the way, this is not a minus sign. This is just a little dash between the phone numbers, right? So anyways, you're multiplying all that together. So they could introduce 15,000 new phone numbers with these restrictions. Pretty interesting. Alright, so you're going to have one more to try out on your own. Pause the video and resume it when you're ready to check. Alright, so it says when tagging birds outside. Alright, so if you ever look at a bird, I know this is kind of weird, but if you ever look at a bird, especially in the US, if you can get close enough to it, a lot of them actually have little tiny bands around them. Not all of them, but a lot of them definitely have those tiny little bands. They get tagged, they get tracked. So anyways, when tagging birds outside, you must give them either a blue, green, yellow, or red band. You need to assign them a 2-letter code and a 3-number code. How many birds can be tagged with this system? Alright, that should really say digit, not number. But anyways, so let's see. So when tagging a bird, you must give them either a blue, green, yellow, or red band. So that's 1, 2, 3, 4 colors to choose from. When we're assigning them a 2-letter code, well, in the alphabet there are 26 letters, and it doesn't say anything about not repeating. And then it says a 3, it should say digit, not number, code. It doesn't specify whether or not we can use 0, so we're going to say sure, we can use 0. So if we include 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's actually 10 different options. So you're going to multiply all this together. 4 times 26 times 26 times 10 times 10, oops, times 10. You would get 2,704,000 different unique tags. So that's how many birds you could tag with that particular system. I do apologize if you didn't get this correct. For one thing, I had the word number instead of digit. And then the other thing would be if you didn't know that you could use 0, right? If you only thought it could be 1 to 9. Be careful with that, because 0 is still considered a digit, and we would want to consider it when we're doing these types of problems. So that's it for this particular lesson. If you need more help with this, ask questions in class or write them down on here, or wherever we got to do this type of stuff. I'll try to answer them as best as I can for you. The more you practice these, especially on the class worksheet, they get a lot easier, and they're actually kind of fun. They make you think about real life situations, and even things that you wouldn't normally think about, you can still kind of make up some kind of cool scenarios. Anyways, I'll see you guys at the next video. Bye.